Welcome to qnawire.
Our question says that it wants us to look at figure 9-62, which shows block 2, which has a mass of 1.0 kilograms, I write that as m sub 2, is at rest on a frictionless surface, so we can ignore the any force from friction, and it's touching ends of an unstretched spring, which has a spring constant, K, of 200 newtons per meter. The other end of the spring is fixed to a wall. Block 1 in the figure, which has a mass of 2 kilograms, m sub 1, travels at a initial speed, which I call V1I for V1 initial, of 4.0 meters per second. And it collides with block 2. And the two blocks stick together. When the blocks momentarily stop, what distance has the spring compressed? So we can go ahead and start with the conservation of momentum to find the final velocity of the system. So the initial block is initially block 2 is at rest, so its initial momentum is 0. The initial momentum of block 1 is m1 times the initial v1 velocity, which is equal to, since they stick together, m1 plus m2 multiplied by the final velocity. We'll call that v sub f. So you can solve for v sub f. It's going to be equal to m1 times the initial velocity of 1 divided by m1 plus m2. Plug in the values for everything in this expression, and it comes out to be 2.7 meters per second. We can now use conservation of energy. So the energy of the moving blocks, which is 1/2 m1 plus m2, so that's the mass of the two blocks together, times the final velocity of the two blocks together squared. When the blocks are at rest, this has to be equal to the potential energy of the spring after it's been compressed that distance. They have to be equal when it's at rest, since it's in a state of momentary equilibrium. So this has to be 1/2 times k times x squared. The 1/2s are going to cancel, and x is what we're trying to solve for. So x is going to be equal to m1 plus m2 times the final velocity squared, all divided by k. And since x is squared, we have to take the square root of both sides, so this is raised to the 1/2 power. Plug in all the values into this expression, and it comes out to be 0.33 meters, which we can box in as our solution to the question.